So this is our fourth lecture, directional derivative and gradients. So last class we discussed about the directional derivatives. Okay, so today we will discuss gradient. So gradient. So before talking about gradient, we will recall directional derivatives. So we know that if f of x y is a differentiable function at x naught y naught, and u1i plus u2j is a unit vector, this is important, then the directional derivative du f of x naught y naught exists and is given by du f of x naught y naught is equal to fx x naught y naught u1 fy x naught y naught u2. If f of x y z is differentiable, then we know that, and u1i plus u2j plus u3k be the unit vector, then du f of x naught y naught z naught is fx u1 fy u2 and fz u3. So from here, this is a directional derivative is dot product of some quantity. So I will discuss what is that. So we have this directional derivative. If you check this directional derivative, this is simply the dot product of fxi plus fyj dot u1i plus u2j. So dot product is the directional derivative is dot product of these quantities. So similarly here du x naught y naught z naught is dot product of fxi plus fyj plus fzk dot u is u1i plus u2j plus u3k. So now I will define what is gradient. So from here, definition of gradient: if f is a function of x and y, then the gradient of f is defined as del f equal to fx xyi plus fy xyj. So del f gradient is fx xyi plus fy xyj. If f is a function of x, y and z, then the gradient of f is defined by del f xyz is equal to fx xyzi plus fy xyzj plus fz xyz. Okay. So simply now we can write du of f of xy is simply del f dot u. So directional derivative is dot product of gradient and the unit vector. So xyz is also there. Okay. So the definition of directional derivative is gradient dot in dot product of u. So now I will define what are the properties of gradient. Okay, so we know that directional derivative is del dot del f dot u. So before going to directional derivative properties, du directional derivative at f of xy, that is in two variable, we know that del f of xy dot u, right? That is del f of xy means fx xy I plus fy xyj, and its dot product dot u is u1i plus u2j, that is equal to this directional derivative. So we know that a dot b equal to a mod b cos theta. Okay, so this is mod del f of xy mod u cos theta. Okay, so this is equal to modulus of del f of xy cos theta y, because we know that norm u is equal to 1 because u is always a unit vector. Therefore, du f of xy is norm del f of xy cos theta. Now, where theta is the angle between, so if this is a del f vector del of x f of xy, and this is u, unit vector u, then this angle theta is called is the angle theta. Now, a directional derivative has maximum value when we know that cos theta has a value always less than or equal to 1. Therefore, du of f of xy has maximum value. When will be it has maximum value? For which angle? When this quantity norm del f of xy cos theta is maximum. Anybody? When is
Theta
it?
equal to 0.
Okay, theta is equal to 0. That means this angle is 0. This angle is 0 means our direction of del f and u both in the same direction, right? Del f and u has same direction, then the directional derivative has maximum value. Then when directional derivative has minimum value, when is cos theta is minimum?
Theta equal to 90 degree.
Theta equal to
Theta
90
equal
degree
to
pi or 90 degree. So that means it has a value minus del f of xy when theta is equal to 90 degree. So that means the direction of u and the direction of del f are opposite. So maximum value when del f and u has same direction, and minimum value when del f and u has opposite direction. Okay, any doubt? So now we will go through a theorem. So the theorem tells us, let f of xy of either two variable or three variable, and let p denote a point in p of x naught y naught or p of x naught y naught z naught respectively, and assume f is differentiable at p. Then if del f is equal to 0, then all directional derivative of p, f at p is 0. Why? Because if you take any unit vector u, we know that directional derivative is del f dot u. So if del f is 0, then directional derivative is 0 for at or then all direction, for all direction. Now next, if del f not equal to 0 among all possible directional derivative of f at p, then the derivative in the direction of del f at p has the largest value. That means del f and u has same direction, that is theta is equal to 0, then it has the maximum value, and that maximum value is del f. And if it has a opposite direction, del f and u has opposite direction, then it has minimum value minus del f. So now we will do a problem. So when is del f has maximum value, or directional derivative has maximum value, if the unit vector is in the direction of del f, and minimum value the direction opposite to del f. So let us use this example. Let f of xy is equal to x square e raised to y. Find the maximum value of a directional derivative at minus 2, 0, and find unit vector in the direction in which maximum value occurs. So first we want to find out maximum value of directional derivative at a point minus 2, 0. The solution. So we know that del f is equal to fx xy I plus fy xy j. So if you differentiate this with respect to x, 2x e raised to y I, and with respect to y, x square e raised to y j. Now the gradient at minus 2, 0, that is instead of x we have minus 2, instead of y 0. then del f of minus 2, 0 is equal to minus 4i plus 4j. Minus 4i plus 4j. Then we have to find out the maximum value of directional derivative. And I told you that the maximum value of directional derivative is at modulus of del f x naught y naught. Okay. So this is the maximal value of directional derivative. So we will find norm of del f of x naught del f of minus 2, 0. So the maximum value of directional derivative is, so we know that norm is root of minus 4 whole square plus 4 square, which is equal to root 32, which is equal to 4 root 2. Now next question is we have to find out the unit vector in the direction in which maximum value occurs. So I told you that the maximum value occurs if both u and del f has same direction. So the maximum values occurs in the direction of del f. Okay, so how we can find the unit vector? So we know that del f u equal to del f of minus 2, 0 divided by norm of del f of minus 2, 0. If you find, so the maximum value occurs on the direction of del f by norm del f, the unit vector. So this is the maximum value uh, of the unit vector. This unit vector. In this unit vector, the our function has maximum value. Okay. So now we will do few problems. So here we have to find out directional derivative. Sorry, del z or del omega. Okay. So I will do this problem and I will share these questions in your WhatsApp group too. So for 33 problem, we have to find out del z. So we know that del z is here x and y are the two variables. So first we will differentiate with respect to x. So cos 7y square minus with respect to x. So 7xy into derivative of this with respect to x is minus 7y I plus, now we will differentiate this with respect to y. So cos 7y square minus 7xy into derivative of this 14y minus 7xj. So this is the del z. Now you find out this and tell me the answer. What will be del omega of 39? So this is very easy because it's like an homogeneous. So here there are three variables x, y and z. So you have to find out fx omega x I plus omega yj plus omega z. Okay. Tell me the answer. Anybody? By root of x square plus y square plus z square I. Tell me. Anybody got answer?
പറയുന്നു. ഇക്കാര്യം ഇവിടെ എന്ന പേരിലാണ് ഈ കിണർ അറിയപ്പെട്ടത്.
Anybody got an answer? Find del omega. Anybody got answer? Is it clear? First you find differentiate with respect to x, and then differentiate with respect to y. You will get y root of x square plus y square z square j plus z by root of x square plus y square plus z square. Now you do this problem. Okay, so similarly you do other problems. So next we will do 41th problem. Find the gradient of fx at the indicated points. So this is del f. We know that del f fxi plus fyj. So this is fxi 10xi plus del f 4y cube j. So del f at 4 2 is equal to 40i plus 4 into 8 24 32. So this is the answer. Similarly you do other problems. And also there is one more question. Find unit vector in the direction in which f increases most rapidly at p, and find the rate of change of f at p in the direction. If you want to do this problem, so we want to find the unit vector in the direction f increases most rapidly. So f increases most rapidly in the direction when u is equal to del f by norm del f. This is the unit vector. And so u equal to del f. Del f is at 1 minus 1 1. So del f is 12 x cube x square y square I plus del f. I will write del of f of xy for this question. 12 x square y square I plus 8 x cube y. So you find out minus 1 1 12 I plus minus 8 j. So u is del f. Del f is 12i minus 8j divided by root of norm del f 12 square plus minus 8 whole square. So this is the direction at which maximum. Okay, similarly you do these problems. I will share these questions in your WhatsApp. Okay. So is it clear?